You are looking at an AI agent controlled by a neural network. The plan is very simple. We will first teach this quadrupedal to walk and then torture it inside an escape chamber for 1,000 years. What does that mean? Well, there is only one way to find out. I am your host, Cosmos, and welcome to my AI training lab. Fellow comrades, where do we begin? Well, to start off, our creature here needs a brain. In machine learning, we call it a neural network. Now I know, I've explained it plenty of times in the previous videos, but in summary, a neural network needs inputs, which it then processes into outputs. In today's simulation, we are using a network size of 512 by 3, which is a decent amount of brain cells. Alright, so let's do a thought experiment. Imagine yourself from the AI's perspective. What observations do you need in order to walk? Well, pretty simple, right? The AI needs vision. Great! We will now strap two big eyeballs into the AI's head. In reality, the AI needs something called proprioception or body awareness. To achieve this, we will extract the rotation, position, and velocity of each limb and feed that into the neural network. This makes the AI self-aware. However, for the AI to learn to walk, self-awareness is not enough. The AI needs further guidance. This is why we will introduce a cube into our simulation. The world position of this cube will also be fed into the neural network as an observation. Great! Now we have something to work with. The agent is trained using a reinforcement learning algorithm, and as such, we need to define a reward function. This is precisely where the cube comes in handy. Quote unquote, we will reward the AI for maintaining velocity in the cube's direction. The cube itself will be repositioned when the AI collides with it. This is so the neural network generalizes to walk in all directions. Ladies and gentlemen, we also need to generalize the velocity. To achieve this, we introduce a new variable called target velocity. Every episode, a random target velocity will be chosen from a bracket. The closer the AI matches this velocity, the higher the reward. And that's it. The agent is now ready for training. Since the AI is self-aware and knows the location of both itself and the cube within the environment, it gradually learns to move towards the cube, as that's precisely the goal of the reward function. It's now time for our first training session. See you on the other side. We now have a working quadrupedal with excellent locomotion skills. It's time for the second phase of training, where we lock the AI in an escape chamber. But before we do that, I have some interesting findings to share. This simulation was ran multiple times, and every time the agent adopted a unique stride. In this particular run, the agent developed dominant hind legs. I also experimented with a variant of our quadrupedal with feet, and the results were very interesting. Safe to say, our original model has the best walking style, and we shall now proceed with it. Imagine being trapped in a room with obstacles and monsters for 1,000 years. If the monster catches you, you die. This is precisely what we are going to do with our AI. But for the AI, a monster is not something which looks scary, but something which terminates its episode and gives it a negative reward. Ladies and gentlemen, introducing Chasers. These cuboids are programmed to directly follow the AI. On collision, the AI receives a negative reward and the episode is terminated. But hold on a second, this AI is self-aware and knows the position of the target which it follows. The agent has no extra sensors to detect the chasers and obstacles. So do we train the AI all over again with new sensors? Nuh-uh, I have something even better. This is me controlling the position of the target. The target itself can be replaced by anything, as the shape doesn't really matter. I can also adjust the target velocity manually. This makes me wonder, what if we train a separate AI to control these values? It's like giving another AI a steering wheel to control the quadrupedal. Think of it as a higher tier agent controlling the placement of the cube and the target velocity itself. This is the agent which will receive a penalty for colliding with the chasers, not the quadrupedal agent. Our job with the quadrupedal is done, and we are no longer dealing with it. To detect the chasers and obstacles, the higher tier agent is equipped with raycast sensors. This is similar to how LiDAR sensors work. We will also spawn random cuboids around the map and reward the AI for collecting it. The purpose of this is to see if the agent can learn to evade the chasers while collecting the cuboids simultaneously. So in summary, we now have a new higher tier agent. It's rewarded for staying alive and collecting the cuboids. It's penalized for getting caught by the chasers. What you see on the screen is one simulation. In reality, there are hundreds of parallel environments behind the scenes. This is a common way to speed up training in machine learning. So yes, the title mentioning 1,000 years is not clickbait. We are now ready for our second training phase. Good luck. Our training was almost a success. While the higher tier agent did learn to evade the chasers, we have an issue. The agent is taking the same path every single episode. This is called overfitting, and it's no different than humans taking the same commute to work every day. The route simply works, and there is no reason to take an alternative path unless there is a roadblock or change in the environment. So from now on, the obstacle placement will be randomized every episode. The number of chases will be increased to 3, an absolute nightmare for the AI. Let's see what the AI learns this time. Our training was a success. As you have seen, teaching AI to navigate complex environments involves understanding neural networks, reinforcement learning, and advanced mathematics. These concepts are hard to visualize and grasp. Fortunately, we now have interactive resources to get started with Brilliant, that is. Brilliant is where you learn by doing, with thousands of interactive lessons in mathematics, coding, and AI. What I love about Brilliant is how they break down complex concepts like neural networks into hands-on problem-solving experiences. Instead of just watching lecture videos, you are actively engaging with the concepts, which is proven to be 6 times more effective for learning. Whether you're curious about how large language models work or want to understand the mathematics behind machine learning, Brilliant helps you build that intuition through interactive challenges. You can learn at your own pace, and their bite-sized lessons make it easy to develop a consistent learning habit. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/cozmouz or scan the QR code on screen. You will also get 20% off an annual premium subscription. The final AI is now ready, and you are about to watch a full 5-minute footage of the agent trapped in the escape chamber. 5 minutes for you, 1,000 years for the AI. Entertainment for you, torture for the AI. This is cozmouz signing out.